Hello students. Now we start with a new chapter, that is ray optics. In this chapter, now the reflection by the spherical surfaces is not in syllabus. So we start with the refraction of light and cover the following topics. Now you already know what is the refraction of light. Refraction is the phenomena of change in the path of light as it travels from one medium to another. The cause of refraction is change in the speed of light as it goes from one medium to another medium. As already I told you in the chapter of electromagnetics waves that the velocity of the light depends on the permeability and the permittivity of the medium. That is, you know very well that is C is equal to 1 upon under root of mu naught epsilon naught in air. That is, it depends on the permeability and the permittivity. And the permeability and the permittivity of all medium is different. So the speed of light is different in different mediums. So as the speed of the light is different, so it deviates from its path and it is the cause of refraction. Now the laws of refraction, the incident ray, the normal ray and the refracted ray at the point of incidence all lie in the same plane. Second law, for the given pair of media and for the light of given wavelength, ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant, and that is equal to the refractive index of the medium. Say it is a slab whose refractive index is mu. This medium is denser medium and the surrounding medium is rarer. The ray of light is incident on this point and it is the point of incidence. Instead of going in this way, it deviates from the path. And again, as the medium changes, it again deviates from the path. When the ray of light enters from rarer to denser medium, it bends towards the normal. This ray is normal, and as the ray enters from rarer to denser, instead of going in this way, it goes this way. That is, it is bending, it is moving towards the normal. And at this point, as it emerges out, it goes from denser medium to rarer medium. It moves away from the normal. Right? Now this is the normal. It is the angle of incidence. This is the refraction angle. Now sine I upon sine R equals to mu. If say I am saying this medium is A and this medium is B, then this is written as A mu B. It means the ray of light is going from medium A to medium B. If it is going from medium B to medium A, then we write it in this way. Means suppose I am saying it is going out at this point. It is going from denser medium to rarer medium. So I am writing B to A. That is, ray of light is going from medium B to the medium A. Now here is the angle sine R upon sine I. As at this point, this is the angle of incidence. Don't take it as R is the angle of refraction always. It is just an alphabet which most of the time we are using for the refraction. But when the ray of light is going from denser to rarer, then this will be the angle of incidence. Now refraction of light, add to your memory. Refractive index of optically rare medium is lower than that of denser medium. That is, if we are taking the ratio of denser medium to the rarer medium, then this ratio is more than 1. And if the ratio is between rarer to denser, then it is less than 1. In refraction, the velocity and the wavelength of the light changes, but there is no change in the frequency and the phase of light. You know the relation V is equal to n lambda. Velocity changes, it means there is a change in the wavelength, but there is no change in the frequency of light. As you know that the refractive index is equal to sin I upon sin R, and in lower classes you have studied that it is the speed of light in air to the speed of light in medium. So this can be written as wavelength in air to the wavelength in medium. Instead of writing A mu m, we can simply write mu. If it is simply mu, it means we are saying that the ray of light is going from air to the medium, and it is wavelength in air to the wavelength in medium. Principle of reversibility of light. If the path of ray of light after number of reflections and refraction reverses, then the light retraces its entire path. What I mean to say that it is the ray of light, it is refracted at this point, and this one is a mirror. When it is incident normally on the mirror, it goes back, and then this. So the same number of reflections and refractions reverses. How it reverses? By putting a mirror, and it retraces its complete path. Now this is a medium A and this one is a medium B. So when the ray of light is going from medium A to medium B, it is sine of angle of incidence to the sine of angle of refraction. But when the same ray, when going from medium B to A, at this point it is also going from B to A, then it is written as B mu A. At this time, this is the angle of incidence and it is the angle of refraction. Now multiply the two. So this will be the relation between A mu B and B mu A. Thank you and have a nice